So, in this problem it has asked to find the Thevenin equivalent circuit for this given figure. Now, in this given figure you can see only one dependent source is there and no independent source is there. So, now this is the circuit case wherever we have to find the equivalent circuit for a dependent source only. Now, for finding this type of to solve this type of circuit for Thevenin equivalent, we need to follow some steps. So, it is bit different from the general approach. So, what is that? So, first point here is in this case. So, in this case the VOC or the VTH value is equals to, first we have to take as 0. VOC means what? So, whatever voltage is available here, so that is taken as your VOC. In this case first VOC is equals to 0. Then what we need? We need to connect 1 ampere source. So, considering that we will connect 1 ampere source at the terminals, which terminal? Wherever we have to find the Thevenin equivalent source. So, at terminals A and B I will write here, at terminals A and B we have to write. Then third point is that we need to calculate the RTH, that is equals to VAB divided by 1 ohm. We will consider that 1 ohm resistance is here and we have to find the RTH in that way. So, how to solve this? So, in this case we have to connect a 1 ampere current source to the terminals A and B. Okay. So, what is that? So, if I redraw the circuit with connecting 1 ampere source, then this is how the circuit will look like. So, the circuit whatever it was given, I am writing it as it is. And here I have to connect 1 ampere source. So, this current source I will connect here and it is the value of this current is 1 ampere and my terminal A and B is here. And the values are given, this as 6 and this as 12 and the dependent current is flowing at this point. Okay. Now, if I do like this, then what will happen? So, in this figure we can find the value of VAB. So, in this figure if we find the value of VAB. So, VAB means whatever voltage is available here. So, this is will be your VAB at this point. So, this VAB will be used to calculate the RTH. So, we need to find first VAB, then we will be calculating our RTH, that is equals to VAB divided by 1. So, 1 ohm resistance here I have written, so divided by 1. So, with connecting this 1 ampere we need to find what is the value of VAB. Now, how do we find that? So, we need to first apply the KCL. So, KCL at where? So, we can see here I will take this node as A and we will apply the KCL here, that means we are going to do the nodal analysis in this case. So, if I apply KCL here, consider one current is here, one current is here. So, let it be I1, so let it be your I2. Okay. If I do the nodal analysis, then what I need to do? I need to consider that all the current are in outward direction and accordingly I have to find the values. So, here one voltage source is given here and this at this point what is the voltage? VAB. So, applying KCL at node A, what we can write? So, we can write here that VAB or VA we can write. So, VA and VAB are basically same, VAB minus what? Minus 2Y, because this voltage is available here, divided by this resistance 6. This is one current again, plus what? VAB divided by 12 I have to take again. So, I2 is what? I2 will be here minus of 1 ampere, because I am considering I2 is flowing in that direction, but actually we have taken a current which is opposite direction. I will write minus 1 is equals to 0. Okay. So, that implies here I will get a circuit value, means if I solve it I will get taking LCM I can solve it. So, it will be 4I minus 2 VAB, okay, minus 2 VAB, then minus VAB is equals to 0. So, here the LCM will be 12. So, it will be equals to 0. So, that implies what I can get here, 4I minus 3 VAB is equals to 0, okay. And since we know that what is the value of I is equals to VAB by 12, okay. So, this value of I, so here, so we know that value of I is equals to VAB divided by 12. So, here in place of I can replace that. So, that implies here I can write 4 into VAB divided by 12 minus 3 VAB is equals to 0. So, if I solve this, so after solving this we can get VAB value is equals to 4.5 volts. So, here you see only one variable is there and you can solve this equation for that. If you take common, so this LCM, this will be 12, okay. So, 4 VAB minus 12 into 3 VAB is equals to 0 and we will get the value of VAB is equals to 4.5 volts. So, this is the value of VAB. Now, what will be the value of RTH now? RTH is VAB divided by 1. So, that is equals to 4.5 ohms. Now, I can represent this circuit as a Thevenin equivalent circuit. How I will represent? So, there will be one resistance value and there will be one voltage value, okay. This resistance value is 4.5 ohm and this voltage value is 12 volt and here the terminal A and B is there. So, I will just quickly recap what we have done here. So, what we have done here, first we have connected this 1 ampere source here, okay, and then after connecting 1 ampere source we have calculated what is the value of VAB, and after how to calculate that, we have applied nodal analysis at node A, and then we have written the nodal analysis equation. Then after writing the nodal analysis equation, we have solved it and we have calculated the value of VAB here by solving this equation. Then once we find the VAB value, then we have calculated the RTH value. Once we calculated the RTH value, then we have represented the circuit with a Thevenin equivalent circuit, where this this is not 12 volt, this will be your 4.5 volt. Okay, there is one mistake here, so let me clarify that. So, if there is a dependent source, the first point here is, in this case the VOC will be equals to 0. So, there will be no voltage source here. So, it will be directly connected, only one RTH value will be here, there will be no VOC value, because in dependent source the VOC value that we have taken or considered is 0. If the circuit has only dependent source, so here dependent source only, okay. If the circuit has only dependent source, then the VOC value is equals to 0, and then the final Thevenin circuit will contain only a resistance. Only a resistance value will be there, and there will be no voltage source, okay. So, this is how we can solve a value. We can solve a problem, or we can solve a circuit where only one dependent source or any two dependent sources there. If there is no independent source, zero independent source is there, then the Thevenin equivalent voltage will be 0. We have to connect 1 ampere current source at the terminals where we need to find the equivalent value, and then the RTH value will be VAB divided by 1 ohm resistance. So, basically we are considering that 1 ohm and 1 ampere resistance was previously here. So, this is how we can calculate if there is only one if there is only dependent source is there in the circuit.